Welcome to Emilac Online Tutorial. Now in this video we'll be looking at how to prove that y divided by dx equals nx to the power of n minus 1, okay, and which is actually the direct method of differentiation. Okay, alright, so and we'll actually be using the first principle to get this done. Now here will be, let's assume we have two variables here, y and x. Now an increase in y will give birth to an increase in x. Alright, so which implies that x is dependent on y, and that is all about differentiation. There is an increase in two variables. Okay, alright, now let's get started. Now if there's an increase in in y, definitely there will be an increase in x. So which implies that y plus an increase in y equals x plus an increase in x, all to the power of n. So this increase is actually called the change of that the small increase in these two variables. Okay, now at this point, now let us make the change in y the subject of relation. So here we have change in y equals open bracket x plus change in x all to the power of n, then minus y, because as y moves over to the right hand side it becomes negative. Alright, but take note that this corresponding change affects only x and not the power. Okay, so at this point now let's divide both sides by change in x, because change in x and change in y is actually the differentiation we're talking about. Alright, so here we have change in x. Alright, so but before we move further, at this point here y is x to the power of n. So here we can see that change in y over change in x equals x plus change in x all to the power of n minus x to the power of n all over change in x. Alright, so now let's take note that dy over dx equals to the limit of change in y over change in x as x tends to 0, or rather as the x change in x change tends to what? 0. And let us take note that change in y to change in x give us this expression. So let us substitute this expression in the above equation. So here we have that this is equals to dy dx will now be limits of x plus change in x all to the power of n minus x to the power of n all over change in x as the x tends to what? 0. Right, sorry, not the x but change in x. Alright, so now we have to employ a theorem in limit that says limit of x to the power of n minus a to the power of n all over x minus a as x tends to a, then equals to n a to the power of n minus a. Okay, now what we need to do to really achieve this result from this theorem here, we have to ensure that this term here or this function here correspond to the function of this theorem here. Okay, so how then do we do that? We can see that x to the power of n minus a to the power of n all over x minus a corresponds to x plus change in x all to the power of n minus x to the power of n and all over, but the denominator seems to be different. You only have what? Change in x. So now the question is, how then do we, make this side of the equation the same as the denominator on the left hand side of the equation? Now we take note that this expression here is the same thing as this, and a to the power of n is the same thing as x to the power of n. Alright, so what we need to do here is to plug in. So we are looking for a way to get x plus the x and the denominator minus x. Alright, that will correspond to this left hand side. So at this point we have to probably employ manipulation. So here you have x plus change in x all to the power of n minus x to the power of n all over x plus change in x minus x. Alright, now if you look at it closely, you will see that this expression will still give you change in x, because x minus x will still give you the x here. Okay, alright, so to that end, here you have the y over the x equals to limit of x plus, let me use change in x all to the power of n minus x to the power of n all over x plus change in x minus x, close bracket. And this case here, as x plus change in x tends to what? 0. Okay, now take note that at this point, if the x tends to 0, so x plus the x also, we tend to x. Alright, and if this is true, if this theorem here is true, that gives birth to na to the power of n minus 1, so it also implies here that our n, then here we have x all to the power of what? N minus 1. Alright, so it implies here that dy over dx equals nx to the power of what? N minus 1. Alright, so we've proven that. Alright, and this happens to be the direct method of differentiation. Alright, so if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be ensured that all of my videos, you will be the first to be notified. Alright, thank you and God bless you.